Hello and welcome to the first lesson in Module 1, which is all about integers. 1.1, in fact, the name of it is integers. Now that word might be unfamiliar to most of you, but you have in fact worked with integers before, and we will find out exactly what integers are here in a second. Today we will be able to compare and order integers, and we will determine absolute value. So compare and order and determine absolute value. We do have a little bit of vocab here to start. Positive and negative numbers, you should know what those are from last year, but it's good to review nonetheless. So a positive number is an integer greater than 0, and a negative number is an integer less than 0. Okay, and we still don't know what an integer is, but we will find that out here in a second. So 1, 2, 3, those are all positive numbers. And -1, -2, -3, those are all negative numbers. They are less than 0. Opposites are two numbers that are an equal distance from 0 on a number line. So for instance, 7 and -7 are considered opposites because they are both 7 units away from 0. And finally, the definition of integers. It's a set of whole numbers and their opposites. Now we have to recall that whole numbers is exactly what it sounds like. You can't have any fractions and any decimals. So for instance, 3.5 is not a whole number, but 3 is a whole number. Okay, so we take all of those whole numbers like 1, 2, 3, 4, 5, and so on, and all of their opposites, so -1, -2, -3, and so on, and that makes up the set of integers. Okay, of course, include 0. Don't forget about 0. Those are integers. And finally, we will learn about absolute value. And absolute value is the distance of a number from 0 on a number line. And I use the example in class. You never hear anybody say, oh yeah, I know how to get to the grocery store. It's -5 miles down the road. Because we don't measure distance with negative numbers. Distance is always positive. So that means that absolute value will always be positive. And we'll see some examples of those here coming up. Okay, the first thing that you need to be able to do is graph integers on a number line and their opposites. Okay, and I'm going to be particular about how you graph these and what your number line looks like. So to start, you're going to draw a nice straight line and put arrows on the end of it. Those arrows signify that you know a number line goes on forever and ever and ever to infinity. Okay, so make sure there's arrows. You're going to put 0 in the middle of your number line. Okay, and we are graphing the integer -3. Okay, all of the negative numbers lie to the left of 0. So we need to count -1, -2, -3. Okay, and in order to graph an integer, all you are doing is putting a nice circle where that integer is. So that is graphing -3. But I also need to graph its opposite, right? It says opposite. Well, the opposite of -3 is +3. So now we're going to start at 0 and go the other direction. 1, 2, 3. And that is where I will graph the integer 3. And that is all I need to see from you. We have graph -3 and +3. Okay, let's try another one. We are going to graph 7 and its opposite. So again, draw a nice straight number line with some nice arrows on the end, and we're putting 0 in the middle. Okay, 7 is a positive number, and it lies to the right of 0. So we're going to go 1, 2, 3, 4, 5, 6, and 7, and we can graph 7. And then the opposite of 7 is -7, so let's go the other direction. -1, -2, -3, -4, -5, -6, and -7. Okay, and then we can graph that integer as well. Next example, we're going to compare integers. Okay, so we need to figure out using inequalities, which one is bigger. And an inequality are just these signs here, those little arrow-looking signs. One means less than, and one means greater than. So between 5 and -5, we have to figure out which one is bigger. okay? And you may have learned last year that a positive number is always bigger than a negative number, okay? And these inequalities might look like alligator mouths, and you might have learned that the alligator mouth always wants to eat the bigger number. So if 5 is bigger or greater than -5, we should draw in the inequality so that the alligator is eating the 5. So 5 is greater than -5. But then we look at example B, and now we have two negative numbers, -10 and -7. Okay, before we had a positive and a negative, we said, oh, the positive's bigger. But what happens when you have two negatives? When you have two negatives, the one that is closer to 0 or the one that is further to the right is always the bigger number. So if we're looking at a number line here, and we've got -7, -8, -9, and -10, the one that is further to the right is -7. So we know -7 is going to be bigger than -10. So we should draw in the inequality so that the alligator is eating -7. And the same holds true for C. We have, how does -12 compare to -21? Well, -12 is further to the right on a number line or closer to 0 than -21 is. So we should draw our alligator mouth eating -12. So -12 is greater than -21, which is a little counterintuitive because you would think, okay, 21 is bigger than 12. But when we're working with negative numbers, it's really the opposite. Okay. All right, finally, we're going to use a number line to order the integers from least to greatest. So you could draw a number line and plot all of those points and then order them. Or we can just list them in order from least to greatest. So I need to find the smallest number from this list. Well, we need to find which number lies furthest to the left. And that's going to be -4. -4 is the biggest negative number. So that's the first number I will put in my list. Okay. The next one furthest to the left is -2. Okay. And after that comes -1. Okay, I'm done with my negative numbers. So after -1 would become 0. And after that would be 1. And finally, the biggest one in the list is 5. So -4, -2, -1, 0, 1, and 5 are those integers put in order from least to greatest. Okay, let's try another one. So right off the bat, I see a really big negative number right here, -8. So I'm going to put that at the bottom of my list. That is the smallest number, -8. Next smallest after that looks like -5. Then it looks like -3. Okay, after that is 0. And then 2, and finally 6. So I have ordered those from least to greatest. Absolute value is the only concept we haven't touched on yet. So if you look back at your definition of absolute value, it was the distance of that integer from 0. Okay, so I'm going to draw a nice quick number line here. We've got 0, -1, -2, -3, -4, -5, -6. Okay, so we're going to count how far away -6 is from 0. So we're trying to get here. We're going to start at 0 and count the distance. So we go 1, 2, 3, 4, 5, 6. So the distance from 0 is 6 units to get to -6. Okay, so the absolute value of -6 is 6, +6. And I didn't explain that these two bars right here mean find the absolute value. So when you see vertical bars, it means find the absolute value. So the absolute value of -6 is 6. Again, absolute value is always positive. Okay, we could do the same with 12. Find the absolute value of 12. Well, we would start at 0 and we would count how many jumps does it take to get to 12. Okay, so if you do that on the number line, you'll find that in fact it takes 12 jumps to get to 12, which seems mind-blowing, I know. The absolute value of 12 is 12. So we could probably take a guess that to count the number of jumps from 0 to negative 20 would be 20. Again, a positive number. Absolute value will always be positive, okay? And that is the end of the 1.1 notes, and your homework is the 1.1 worksheet, which can be found on Schoology. Thank you.